Hi, this is Alex from devstories.eu, Kubernetes and Helm Fundamentals, Episode 9 of 10. Building a cluster from scratch is a great learning exercise, but when you scale to hundreds of microservices, you do not want to manage the control plane yourself. You want the cloud provider to do the heavy lifting so your engineers can focus on shipping code. That is exactly what an enterprise Azure implementation of Kubernetes and Helm looks like. In a standard Kubernetes architecture, you have a control plane making global decisions and worker nodes executing them. Keeping that control plane highly available is notoriously difficult. An enterprise client deploying on Azure typically uses Azure Kubernetes Service, or AKS. AKS abstracts away the control plane. Azure manages the API server, the scheduler, and the key value data store. Your operations team is only responsible for the worker nodes that actually run your applications. So how does an application get from a developer's machine onto those worker nodes? This is where Helm comes into the workflow. An enterprise application rarely consists of a single container. It is usually a collection of microservices, each needing its own deployments, services, and configurations. Instead of managing dozens of static YAML files, developers package these resources into a Helm chart. A chart acts as a single, versioned blueprint for a microservice. Because Helm uses templates, developers can write the structural logic once and inject different configuration values depending on whether they are deploying to a development, staging, or production cluster. Before anything runs, the application code is built into container images. These images are pushed to a secure storage location, like a container registry. Helm charts themselves can also be packaged and pushed to a registry, which allows enterprise teams to treat their infrastructure definitions exactly like their compiled application code. Here is the key insight. When a release pipeline triggers a deployment, Helm evaluates its templates with the environment-specific values and sends the final manifests to the AKS API server. The AKS control plane reads this desired state and starts scheduling pods onto your worker nodes. The nodes reach out to the container registry, authenticate securely, pull down the specific image versions, and spin up the containers. Kubernetes constantly monitors this state. If a worker node crashes, the control plane immediately reschedules its pods onto healthy nodes to maintain the replica count defined in the Helm chart. Once the pods are running, they need to receive traffic. A Helm chart will typically include a service definition to expose the application. When this is deployed to AKS, Kubernetes talks directly to the underlying Azure infrastructure. If the service requests a public entry point, AKS automatically provisions an Azure load balancer. This load balancer takes incoming external traffic and securely routes it into the cluster, distributing it across the healthy pods. Your developers never had to touch the Azure portal or write specific cloud routing rules. They simply defined a standard Kubernetes service in their Helm chart, and the managed cloud platform handled the physical network provisioning. The real power of this enterprise architecture is the clean separation of concerns. Helm standardizes how the application is defined across environments. The registry secures the versioned artifacts, and the managed cloud platform ensures the underlying infrastructure actually stays alive to run it. Thanks for spending a few minutes with me. Until next time, take it easy.